So what I have here is a Python program that plays the game of tic-tac-toe. And we are not going to look at very much of this at all. I'm just putting it up here because I happen to have it on hand. All we are really going to look at are these three lines here, and then a little bit at the init board function and the display board function. If we look at the board variable here, we see that inside the init board function, we are changing it, we're modifying it, right? So if you see right here on this line, for example, we are putting X in the center position of the board. And even though we are doing that, we're making that change inside the init board function, when we go to display the board, those changes that we made down here inside init board are also apparently changing this variable board up here in this function called main. So just to prove that, let me go ahead and run this. And if we look at the results of the display board function, we see that X in the middle square, as well as the other numbers and all of the other squares. Anybody want to ask a question at this point about my point or what I'm getting at, or the code in general? Okay, so what I want to illustrate here is, let's try doing this same thing with an int variable. Oops, sorry, I'm typing C++ here. So I'm gonna let I equal 7. I'm going to, after I initialize the board, after I display the board, I'm going to print the value of I. And then inside init board, I'm going to change the value of I. Maybe I'll just do it at the, I don't know why I don't just make this tall. Okay, so how about if you each go ahead and type in the chat and let me know what the output is going to be, what the value of I is going to be that gets printed by this print statement. Okay, so far we have 2 votes for 42, 3 votes for 42, and 4 votes for 7. There's a not sure. Not sure is certainly a fair enough response. So it turns out in this case that the changes that we make to I inside the init board function do not affect the value of I back here in main. Okay, so if I run this, what's going to come out is a 7. Let's go ahead and see that for ourselves. And there's my 7. Okay, super, super critical that we get this. So if we finish lecture today and you're still not sure you're understanding that, just study the lessons. If it still doesn't make sense, make sure you talk to me or Kyle and get this figured out. This is super important. Anybody who said 42 want to say, oh, I get it now? If not, that's okay. That's why we're here. And as a matter of fact, this is all just sort of preliminary to what I'm going to tell you anyway that I would have told you if this was your first time writing functions. But just to say a little more about what's going on here. When I say board gets something like this, that's an object. And so when I pass that object to a function, what's being passed is not actually a copy of the whole object, but instead we just pass a reference to the object. Okay, so inside here, board is actually just a reference to some other, the object itself. And so the changes that get made here, and that's actually also the same thing here, right? The word board here, when I use that, it's actually a reference to an object. And so this variable here, board, is actually, technically speaking, hopefully this isn't so technical that it'll confuse you, but technically speaking, this variable board is a different variable from this variable board, but they are both references. So when I say a different variable, that means if you were to look inside your computer's memory, there would be two different memory locations. One for main's variable board and one for init board's variable board. But they would both be references to an actual object. And they would be references to the same object. All right, so that's, if that's confusing, that's okay. We're going to be spending a lot of time today trying to work that out. I see a raised hand. You want to just go ahead and speak out or type something in the chat?
So because they're two different objects making a reference, that's why in the function it doesn't get changed. Okay. So okay, because I in the main function is 7 and it's referencing something else, that's why it doesn't get changed to 42 when it's referenced in init board, because they're two objects, right?
Actually just the opposite of that. Let me try again. Okay. So in the case of I, there's no, I is a primitive type. So we're not calling it an object, at least in this context. It's just a primitive type. And so what happens, there's no references involved at all, right? When I call the init board function and I pass I, all I'm doing is I'm passing the value 7. And then this I down here in board, which is a separate variable, is just going to be a copy of that same value 7. And so when I change it to 42, what's being changed is just this actual variable I down here in init board, and it doesn't affect this variable I up here in main. That should actually be the simple to understand part. Okay, I shouldn't say simple.
Okay, but okay, that makes more sense.
Okay,
Thank you.
So that's the easy to understand part. I think the hard to understand part is what's going on with board, right? When I board, this variable board is actually not a primitive type. So it's a reference to an object. And so what I'm passing here when I call init board is I'm not actually passing the board itself. I'm passing a reference to the board. And so any changes that I make inside here actually end up changing the same board that was a reference up here. Okay, so I'm going to explain that in a completely new example from scratch. So we should probably give that a try. My main reason for throwing this out here is just for those of you who, I don't know, understood this when you took it in 115. Hopefully it'll transfer over into C++ pretty easily. But if this makes absolutely no sense at this point, that's okay. We're gonna start over from scratch here on it anyway. But just the bottom line here, to just summarize what we saw so far, is that primitive types, the changes don't affect the calling function. With objects like board, changes down here do affect the calling function. So, and so just to give you a little bit more of a preview, we're going to see exactly the same thing in C++, except, or we're going to see exactly the same two options in C++. The difference in C++ is that we get to choose whether it's going to change or not, whether it's going to be a reference or just a primitive type. In Python, we have no choice. If it's a primitive type, no matter what we say or do, when we say I gets 42, that's not going to affect the calling function. We don't get to choose. All right, so enough about that. Let me just move on to our C++ example. So this is the program that we ended up with last time. Hopefully, it won't be confusing to just start right at the beginning of lecture with a somewhat complex example from last time. But go ahead and just stare at that for a minute. Let me know if I need to go over it some more, or if there's certain things about it that are still confusing. But you'll notice in this example, so far anyway, we can't really even tell which technique C++ is using, right? Because there's no examples in here where we actually changed any of the parameters. So we're gonna change that though. All right, so I'm gonna dive in, and now I'm going to just start my example. And what we're gonna do is we're going to reorganize this program. I notice I'm looking at my main function. I notice, there's some couts and cins. It's usually best to avoid that sort of detail in main. And also I noticed that if I look at these four statements, I can say, oh, well, those four statements comprise a task. The task of those four statements is get the dimensions of the box, right? And then these three statements, if I look at those, I can say, oh, the task that those three statements perform is draw the box. Okay, so anytime you can see a sequence of statements and say, here's the task that this sequence of statements performs, always a good idea to pull them out and make a separate function. So what I'm going to do is I'm going to create a function named get dimensions. I'll fill in the parameters later. And it's just going to be these 4 lines. Okay. And then, of course, I need to call get dimensions here in the place where I took them out. Any questions about what I just did? I know I kind of did a lot of moving things around, but hopefully that makes sense. I just replaced these 4 lines of code with a function call to get dimensions. And then I'm going to do the same thing with these 3 lines of code. I'm going to create a function named draw box. And I'm going to take these 4 lines of code, cut them out of, 3 lines of code, cut them out of main, and put them inside my draw box function. Okay. And then, of course, call the get box function from there. Okay, so I'm all set up except that I need to match my parameters and arguments up now, right? So let's start with drawbox. In order to do my job as drawbox, I need to know the width and the height of the box. So I'm going to say int width, int height. And then when I call drawbox, I have to send those 2 things, width, height. Okay, and then I'm going to for now, I'm just going to put exactly the same thing in get dimensions. Hopefully that's somewhat intuitive. Int what? Geez, height. Okay.
I think it's not get box, but it's draw box for that.
Thank you. Okay. So, oh, and then of course I have to put my prototypes up here. Okay, so let's try this out and see what happens. Okay, we compiled fine. Enter width, let's say 5. Enter height, let's say 8. All right, anybody want to guess what's going on here? This is my loop and it's still just running. I'm gonna hit Control C to exit out of the loop and get back to the command line. So what's happening there is, so first of all, when I say int width and int height, when I declare those variables, I think we talked about this last time, what do they start off being equal to?
What's supposed to be started in the memory previously?
Whatever was sitting there in the memory previously, right? That's sort of a hard sentence to say, and it's long. So what we're going to do is we're just going to say, from now on, when I ask that question, we're just going to say junk. Okay. Yeah. When I first declare width and height, what's going to be in those variables is garbage or junk. So I call get dimensions. Turns out nothing I do in get dimensions changes the value of width and height back out here in main. So by the time I get to drawbox, what I'm sending for the width and the height is still just garbage. And so apparently they started off being equal to something really big. And so we just ended up with a loop that is going, eventually would stop, right? But it might take hours or something before we were done. Before the for loop reached the value that was being stored in width or height. Anybody want to ask a question about what's going on there? Why we're getting that weird output?
Do you think maybe it's because you're calling integer width and integer height in your main instead of in get dimensions?
Well, no, I don't think that's why.
Okay.
Like, I mean, I'm calling them width and height right here. So the reason is simply that I've declared width and height here. They have garbage in them. And then the rule in C++ is that no matter what I do to width, given the syntax that I have now, no matter what I do with width, and no matter what I do with height inside this function, that's not going to change the value of this width and height. That's just the rule in C++. And just to emphasize, this variable width here, main's width, is unrelated to this variable here, get dimensions width. If I go look in my computer's memory, those are going to be 2 separate memory locations in the computer. I just happen to use the same name both times. Okay.
Okay.
So what's going on here is, well, I don't think I want to say that yet, but I want to make sure that, or I want, hopefully everyone understands why that's happening. It's exactly the same thing that would have happened in Python, right? That's what I illustrated with that variable at I that didn't get changed before. Remember, I had I gets 42 here. And when I printed it out I here, I didn't get the 42, it just stayed 7. It's exactly the same thing that's happening here. So that's the expected result. I mean, it wasn't expected perhaps for you guys because we haven't discussed how C++ treats this, but now that I've said C++ treats this the same way Python does, that should be the expected result.
Okay, that makes more sense now, actually.
Okay. So what I said before was that in C++, we get to choose, right? If this was Python, we would now be stuck. There would be no way for us to make this work. Well, the only way we could make this work is with a return statement, but you can only have one return statement in a function, so we'd have to have two separate functions, one to get the width and one to get the height. So we'd have to completely rethink our approach. In C++, this is very easy to fix. We can just tell C++, okay, instead of passing a copy, I want you to pass a reference instead. Okay, the way we do that in C++, we just put an ampersand right there. And all that means is it's just kind of, you're waving your magic wand and you're saying, okay, now when I call get dimensions, instead of passing the actual value that's stored in width, I'm going to pass a reference to the variable width. And I'll talk about this more in a minute, but when I say what I'm passing is a reference to the variable width, what that means under the hood is I'm passing the memory address of that variable, but we'll talk about that more in a minute. Okay, so let me just prove that this actually works. Let's see, I need to update my prototype also. And then I'm going to come over here. I'm going to compile it again. And then I'm going to run it again. I'm going to say width 5, height 8, and there's my box. Okay. Just taking a minute, I want you to think for a minute. I want you to answer this question on a scale from 1 to 5. So type in the chat something between 1 and 5. 1 means you are completely lost with this. 5 means you get it, makes total sense. All right, so that's pretty good. Still some more to talk about, and that's fine because we're going to be talking about this for probably by the time we're done talking about this, you'll be sick of it. So bear with me, but that's good to know that we're at least sort of on the right track here. All right, let me think about what I want to do next year. Oh my gosh. I have my notes on this other computer that I hate. Like it shut down on me, so give me a second. It's almost like a joke. What? Yeah, okay. Bad idea. Thought that was a great idea. All right, I think that's pretty much, oh, okay, I know what I want to do next. Okay, what I'm going to do now is I'm going to go into excruciating detail about what happens at every step in the execution of this code. I'm going to do that for a couple of reasons. This is more detail than I think probably most instructors would do, probably more detail than you're going to see in your textbook. But in my experience, for many students who are feeling a little bit fuzzy about it at this point, when they see what's really going on behind the scenes in the computer's memory, the light bulb kind of goes on and it makes sense. And then secondly, you know, 98% of the time in your programming, you're not going to need to understand this much detail. But every once in a while, there's going to be a situation where you're trying to debug your code. You can't figure out why it works. And you really do need to have this level of understanding of what's going on behind the scenes. So what I'm going to do is I'm going to use an Excel spreadsheet to, oops, didn't mean to do that, keep track of or to represent the computer's memory. I don't really need it to be that huge. Let's just do something like this. Okay, and what I'm going to do is I'm just going to start at the top of my program and I'm going to pretend I'm the computer and I'm going to execute each statement one by one, and we're going to see what happens in the computer's memory at each step along the way. The one thing I am going to need is some arrows. So let me just go ahead and create a few arrows so that I'll have them. Actually, I think I just need two. Okay. All right, here we go. So first thing that happens is I see this statement int width. What that does is that means that there's going to be a memory location in the computer's memory that the computer is now going to reserve for storing this value. And it's going to be named width. And I'm going to be even more specific and just say this is the width that belongs to main. Okay, so that's what happens when we say int width, and then as we've talked about previously, what's being stored in there now is just garbage, so we don't know what it is. Okay, same thing happens with height, right? So this second variable that I've drawn a picture of over here, I'm going to call that mains height, and when we first declare it, it's just garbage. Okay. So now I'm on line 15 and I'm going to call get dimensions. So here we go down to get dimensions. When a function is called, the first thing that happens before I start executing the statements inside the function is I got to set up those parameters. So I've got, and remember, parameters are always just declarations, which means that they are going to cause a new variable to be allocated in your computer's memory. So when I say int width, that means I'm going to have another variable down here named width, but this is going to be get dimensions width. Okay. And I'm also going to have a variable down here, get dimensions height. Okay. The difference between, or a difference between parameter declarations and regular local variable declarations is that they don't start off, or parameter declarations do not start off life being equal to junk. They actually start off life being equal to whatever was passed by the calling function. Okay. In this case, what was passed by the calling object, by the calling function was a reference to mains width. Okay, so I said before, when I say a reference to, that really means the memory address of. So just imagine for a second, I'm gonna, let's say mains width, let's say for example, that is stored in the computer in memory location for a 7C. Okay, and then let's say mains height is stored in the computer at memory location for a 80. Whoops, 80. Well, I'll try 80. Okay, so what that means is when because of this ampersand right here, when I call get dimensions, instead of passing whatever value is stored in here and making a copy of it here, which is what happened when we ran the program and it didn't work. Instead, what I'm going to pass down here is the memory address where mains width is being stored. Same thing for mains height. Okay, So just to back up for a second, I'm starting to execute the get dimensions function. I'm trying to set up the parameters. And so I have to figure out what the parameters start off being equal to. And in this case, get dimensions width starts off being equal to the memory address of mains width. Get dimensions height starts off being equal to the memory address of mains height. That's what a reference is. A reference is just a memory address of some other variable. Okay? Anybody want to ask a question before we go on? I know this is probably feeling a little like a lot of details right now. That's okay. I think our next move is actually going to simplify things a little bit.
So the and right after the integer allows you to rewrite that memory location essentially?
It's a way of allowing the get dimensions function to have access to the corresponding argument back in main.
Okay.
But it's a very carefully regulated way, right? It's not just saying, oh, go ahead and do whatever you want. It's more carefully regulated than that. So I can, a reader can see, oh, this function is going to, have the ability to go back and change this variable up here because I see this ampersand sitting. Let me just say, this is a very accurate picture. And let me just say one more thing in case it's not clear to everyone. When I put the 4A7C here in parentheses, what I meant was this memory location right here with the question marks in it, that is memory location 4A7C. All right, maybe that was obvious, just wanted to make sure. Okay, so computer scientists, when we're drawing pictures like this, and we do this a lot, okay, so you're going to be seeing lots of pictures with, boxes with numbers in them and arrow and things like that. When we do this, we don't actually put actual memory locations in there for two reasons. One is it's very complicated, but the main reason is we don't actually know what the memory location is going to be, right? And every time we run the program, it could be a different memory location. So instead of actually putting memory locations here, we just represent the fact that this variable contains the memory address of this variable by putting an arrow in there. Actually, let me delete that first. Putting an arrow in there and making it point up to the variable whose memory address it contains. Okay. Yeah, I didn't. Let me try that again. Good enough. Hopefully you can tell that that's an arrow. Right, and then same thing here. What is contained in this memory location is actually the memory address of mains height, and I picture that by making it point up to mains height. There we go. All right, and then that means I no longer need to know what memory location that is, and I no longer need to know what memory location is. All right, so hopefully I did that in sort of a roundabout way, right? I introduced all that stuff about memory locations. I could have just skipped that and done the arrows, but I really wanted you to have the sense of these are memory locations. What's being stored in get dimensions width is actually the memory address of mains width. Any questions or comments? Backing up again, big picture, where we are is now we have just finished setting up the parameters for get dimensions, and we're ready to start executing the statements inside get dimensions. All right, let's keep going then. So here I am, I'm executing the statement. I see enter width gets printed on the screen. User enters, let's say the user enters a 7. So where's the 7 going to go? Well, if this was not a reference parameter, the 7 would go right there. But because it's a reference parameter, what that means is, no, you can't put the 7 there. What you have to do is you have to follow the arrow and put the 7 wherever the arrow is pointing. Okay. And then same thing again, the words enter height appear on the screen. Let's say the user enters 13 for the height. So I go to put the 13, I go to store the 13. I can't store the 13 here because that's a reference. Instead, I follow the arrow and I store the 13 wherever the arrow is pointing. Of course, right in the middle of where the arrow is. Okay. Any questions about what just happened? We're at the bottom of the get dimensions function now. So when I get to the bottom of a function, all of the variables associated with that function are deallocated. They go away. Okay. And in terms of our picture, we're going to say they go away. What's really happening is just that they're being deallocated, right? The computer saying, okay, I'm not using these variables anymore. You can go ahead and use them for something else. I don't need them anymore. Okay, and I could get rid of the arrows too. And so now we're done with get dimensions. We're back here in main and we're about to execute the draw box function. And this is a picture of our memory, which is what we wanted, right? We wanted whatever the user entered for width to be stored in main's width and whatever the user entered for height to be stored in main's height. Any questions about what just happened? So hopefully it's clear that that's just a really complicated way of making it so that the changes that we make down here to width and height actually affect the values of width and height up here in main. And let me say just one more thing, and that is the fact that they're named width and height down here, and they're also named width and height up here, is irrelevant. If this had been X and Y, same thing would have happened. Right? So it would have been, you know, get dimensions X, get dimensions Y. I would have put the value, and X would have been the memory address of main's width, and Y would have been the memory address of main's height. The names being the same is just coincidental. All right, so we keep going. Call draw box. We actually did the hard part now, right? We did the pass by reference part. So now we're going to do the easy part, but I should just go through at least one more step with you to make sure you get to at least see that. So I'm calling draw box. So I come down here. As I said before we start executing the statements inside draw box, we have to set up the parameters. Okay, so I'm going to have a parameter named width. It's going to be draw box's width. So 2 more memory locations in the computer's memory being used now. Okay, so what goes in draw box's width? Well, in this case, there's no ampersand. So what that means is just put whatever value is being sent right there into this new variable named width. So going back up to main, when I call draw box, I said, okay, I'm calling draw box. I need to send 2 values. I'm going to send the value being stored in width and the value being stored in height. So I'm sending 7 and 13. So when we get to draw box, we see, okay, well, that first thing being sent was a 7. So that goes here in my first parameter. And the second thing being sent was a 13. So that goes here in my second parameter. Okay, notice again that that didn't have anything to do with the names. If I had reversed the order of these parameters, it would have reversed the order of the values here. If I had called this X and Y, then 7 would have gone into X, 13 would have gone into Y. So the names have nothing to do with it. Any questions? All right, so I think I'm not gonna keep tracing through every step here. Basically, we've got width and height inside draw box. So I'm gonna call the functions required to draw the box. I'm gonna get a 7 by 13 box. When I'm done with drawbox, as I mentioned before, all of these variables associated with drawbox get deallocated. And I go back up to main and I'm done with my program. Okay. All right, any questions about that? All right, so I guess just to summarize a little bit, got two different options for parameter passing in C++. You can pass by reference or you can pass by value. When you want to pass by reference, you just put that ampersand in there, and that means you're using pass by reference. Normally, you want to use pass by value whenever possible. That should be the default. You just use pass by reference when you need to have information going from the called function back up to the calling function. Okay. In lesson 7.1, what I just covered, this excruciating detail part, that was lesson 7.2. Just to kind of let you know where to go when you need something. And I highly recommend that you read these lessons because I'm covering most of it in lecture, but there's going to be bits and pieces that I'm leaving out because we're doing this sort of triple time or something. And so I don't think it'll take you a lot of time because you will have seen most of it already, but you may pick up a couple of things that I skipped over. So just to let you know, lesson 7.1, what I do there is I list 7 ways to describe the difference between pass by value and pass by reference. Okay, and then in lesson 7.2, that's where I do what I just did. Details of each parameter passing mechanism. And then I also have some things there, some links to programs there that I call trace programs. And basically what those are is I've come up with some programs that are really tricky, where you really need to understand pass by value and pass by reference really well in order to get the correct answer. And so I highly suggest that you go through and you predict what you think the output of those programs is going to be, just to make sure you've really got this. And then if it turns out that you don't, then you can follow up with me or Kyle or a tutor or something to get that figured out. And then lesson 7.3, I think you already had to go through lesson 7.3 in order to figure out random number generation. Okay, so that's lesson 7. I do want to just mention one thing from lesson 7.1, which I actually intended to mention previously and forgot. And that is, I want to talk a little bit about the direction in which information is flowing here, because I think that's the easiest way to decide whether you need pass by value or pass by reference. So let's look at when main calls draw box. And I realize that's backwards, right? Because main calls to dimensions first, but I want to look at this situation first. So here's the calling function. Main is calling draw box, so we'll call draw box the called function. This information about width and height, which direction is that information going? Well, main is telling draw box the values of width and height, right? So the information is going from the calling function to the called function. And usually in your code, that's going to mean down, right? So going down from the calling function to the called function And so in that case, we use pass by value. But if you look at this information, at the relationship between main and get dimensions, the values of width and height are going from get dimensions to main. So they're going from the called function back up to the calling function. And that is the situation where you need pass by reference. Okay, so you could think of pass by value as being one-way flow of information down to the called function. Pass by reference is flow of information back up to the calling function. It actually turns out that it's two-way. Like you could use pass by reference and you could print out the value and then change it so the information will be flowing both ways. Okay. Anybody want to ask a question? I realize that if this was not clear in 115, there's a fairly good chance that this still probably feels a little fuzzy. So be okay with that. Just make sure you take the time, go read through those lessons, and then let somebody know if you're still not good. Okay. In our remaining time, what we need to talk about and of course my computer's totally stuck, is value returning functions. So to relate this to Python a little bit, let's go look at that code that we had before. Let me just note that, for example, in this init board function, there was no return statement, right? In C++, if there's no returning, we call that a void function. Display board, I know we didn't look at that very carefully, but I'm just, you don't need to understand it. I'm just going to highlight that and say, look, there's no return statement. So in C++, that would be a void function, just like we've been seeing. However, let's look at, so here's a function called make list of free fields. And there's this return statement that returns something back to the calling function. So that's a value returning function. That's what we're going to talk about right now in C++. Let me just go ahead and do an example. All right, so in Python, a value returning function looks pretty much the same as a function that doesn't return a value, except that you don't have a return statement, right? I might have said that backwards, but hopefully you know what I mean. In C++, you actually have to indicate that the function is a value returning function. And not only that, you have to say what type of value it's going to return. So I want to do an example where we write a function named power. And this function is going to take two parameters, a base and an exponent, and it's just going to return the answer. So if I was going to call this function, I might say something like this. Okay, notice this is different from any of the functions that we used in the last example that I just deleted all of. In that example, every time I called the function, it was always just on a line by itself, right? Okay, so here's the function call. It's on a line by itself with a semicolon at the end. That's how you call a function that does not return a value, or a void function. This is different, right? This is not on a line all by itself with a semicolon at the end. So what I want you to understand is that with a void function, the way we call it is we use it in the place where we would normally put a complete statement. With a value returning function, we normally put it in a place where we would expect to see just an expression, not a complete statement. So I think that's a fairly important distinction to make in terms of being able to call functions correctly. So
I'm sorry, a what statement?
Sorry, I don't remember the context of where I used
When
the word.
using a function that doesn't return something, we normally put it in the place where we would put a something statement.
An expression.
An expression.
Well,
Okay.
I'm sorry. Well, let me just say it again from the start so we make sure I have it right. So if you're going to call a function, if you're going to call a void function, right? So I'm going to use that term instead of the term a function that doesn't return a value. If you're calling a void function, you put it in the place where you would normally see a complete statement. If you're calling a value returning function, you would put it in the place where you would normally expect to see just an expression. So, for example, in a cout statement, I might say something like cout 4 times hours worked, right? I would expect to see an expression right there. So that's the same thing I have here because I'm calling a value returning function. Okay, any questions?
That makes sense. Thanks.
All right. So let me get rid of this extra stuff here. I'm just using a one-line program here. So let's go ahead and write our power function. So the very first word you type when you're going to write a power function, I'm sorry, when you're going to write a value returning function is the type of value that's going to get returned. So I'm going to say int, because I'm going to write a power function, but I'm not going to worry about floating point numbers. It's just going to be all integers. So int instead of void, and then the name of the function and the parameters. Okay. Time out just for a second here. I need to plug my computer in or it is going to die. Hold on. Okay. All right. So then basically what we're going to do is we're going to have a return statement inside this function that returns a result. And then the idea being that in between these two lines is where we're actually going to figure out what the result is, okay? So in Python, the difference between a non-value returning function and a value returning function when you write the function is simply that a value returning function has a return statement in it. In C++, there are two differences instead of just one. In C++, one of the differences is that you have to put a return statement in there somewhere. But the second difference is that the very first word you write is not going to be void. The very first word you write is going to be whatever the type is that's being returned. Okay, so the rest of this you don't really even need to see. This isn't, what I'm about to type isn't about value returning functions, but I'm just going to put some code in here so we can see it work. I'm going to say, I'm going to start result off being equal to 1. And then I'm going to multiply it by itself exponent times. Okay. Any questions about the syntax here?
Wouldn't you also have to add the line above into main that I forget the exact word, but
The
is
prototype.
Yeah.
Yes, I also have to include a prototype that is every time you ever define a function. And for me anyway, that's always just like the very last thing I do before I hit the run button. So I haven't quite gotten to that yet. But yes, you're right. The short answer to your question is yes. There was something else I was going to say. Anyway, so I'm going to go ahead and run this after I type my prototype in. Let me go ahead and do that. Before I run it though, someone tell me what the expected output is going to be. In other words, anybody know what 2 to the 8th is? All right, had that memorized, right? So
Ideally.
okay, so I actually I can't resist this little speech that I'm going to give that's a complete digression, but in my opinion, being super comfortable with the powers of 2 is really going to help computer science majors out a ton. So it's something I would just try to get a handle on as soon as you can. And so what I do is I have memorized some of the powers of 2. For example, I know 2 to the 5th is 32. I just have that burned into my brain. I know that 2 to the 10th is 1024. I just have that burned into my brain. So if I'm faced with 2 to the 8th, what I do is I say, okay, I know 2 to the 10th is 1024. So if I want to get 2 to the 8th, I just need to divide by 2 twice. So 1024 divided by 2 is 512. 512 divided by 2 is 256. So I can pretty much within a second or two tell you that 2 to the 8th is 256. All right, end of digression. Let's go ahead and run this and make sure we actually get the correct answer. Okay, there's my 256. Any questions about value returning functions? If you look at the lesson, I'm going to talk a little bit more there about maybe how to decide whether to use a void function or a value returning function. Different programmers will actually tell you different things on this. For me, basically, I would use a void function unless the function really does nothing else other than look at its parameters and determine some sort of a single result based on its parameters. That's what this function does, right? So for me, if there's any input or output in there, I'm not going to make it a value returning function. I think that might actually be. Oh, and yeah, and the other thing is if there's more than one result, then I'm not going to make it a value returning function. I'm going to just keep it a void function. Another way of looking at it, or at least let me put it this way. The way I look at it is I use a value returning function when the function is really very closely matched with what a function would be in algebra, right? In algebra, a function is just something that takes arguments and returns a value, and it always returns the same value, one single value based on those two, based on the argument or arguments. There's no input or output or anything like that. But the bottom line is use whichever one is going to result in the clearest code, right? There's no, having value returning functions doesn't give you the ability to do something new. We could always survive without value returning functions, just like we could always survive without functions at all. But you could always use a void function instead of a value returning function. The only point of having value returning functions is to make clearer, better code. So just look at your situation and decide for yourself whether you think it's better with the value returning function or whether you think it's better with the void function. All right, anything else about this example? Basically what I have planned here is I'm just going to do one more example of a value returning function, and then I will be done talking about functions.
Could you explain why the main function doesn't need a return function anymore?
Doesn't need a return statement?
Yes.
Okay,
For
well,
each
the main function never needs a return statement, and the reason is that C++ has just in the standard it says that, well, even though this is an int function, as programmers, typically we're not thinking of it as an int function. We're thinking of it as a void function. In fact, in other programming languages such as Java, it is void. So we're going to make it so that the programmer doesn't actually need to put a return statement in here if they don't want to. That's just the way that the C++ standard is written.
Okay.
If you want to put a return statement in there, I'm okay with that. Different instructors will tell you different things. Like I know that there are some instructors who say that you have to put the return statement in there, just because it's better for some reason to put it in there. So you may have to just pay close attention to what your instructor says. In this case, I don't see any reason to put it in there, but if you want to put it in there, it's fine with me.
Thank you.
All right, so sometimes a value returning function will return a value of type bool. That's a fairly common situation. And I'm going to sort of call it out as a special situation because typically what you're going to see is that if you have a bool function, the way it's going to be used is as a condition in an if statement or a while loop or something like that. So I'm going to do an example. I'm going to write a function called isLeapYear. And that function is going to return true if the argument is a leap year, and it's going to return false if the argument is not a leap year. So the way that you would probably see a function like this being used, being called is, okay, let's just do enter a year. In year, better declare that variable. Oops. And then I'm going to say, all right, if is leap year, oops, I think leap year is one word, right? If is leap year year, see out leap year. Else, see out not a leap. Okay, so you can see how I am calling that value returning function and putting it where you would normally expect to see a logical expression, right? Which makes sense. A logical expression is an expression that turns out to be either true or false. And a bool value returning function is a function that returns either true or false. The second thing I would say is that it's very, very common. Usually it's going to result in clearer code in most cases if you name your bool returning function with the word is in front. And hopefully you can see how that sort of helps it to read more like just sort of straight English. If is leap year year. Yes, I do see it here. And now that I'm in the middle of this, I'm trying to remember whether I usually uppercase that or not. I'm going to go with lowercase for now, despite what is grammatically correct. Okay, so let's go ahead and write the is leap year function. I don't want to belabor the details too much because the details don't really have anything to do with understanding value returning functions, but so many of you, typically when I do this in class, I ask people if they know what the details are and how to determine what a leap year is or not. And usually, typically like 70 to 80% of the students think that if the year is divisible by 4, then it's a leap year. That doesn't turn out to be the case. It turns out to be a lot more complicated than that. And if we were in an introductory computer class and we had time, I would probably beat that to death a little bit, but I'm just going to go ahead and type this code in for you. I'm going to say if the year is divisible by 400, then I'm going to return true. Absolutely no exceptions. I can tell you right away, if the year you give me is divisible by 400, then I know it's a leap year. Right? Now that I've gotten the 400s out of the way, I can say unequivocally that if the year is divisible by 100, then it is not a leap year. Okay, so none of us here were alive in the year 1900, but if we had been, it would have been a year that was divisible by 4, and yet it was not a leap year. And then finally, I'm going to say if year modulus 4, because so I've taken care of years that are divisible by 400 and years that are divisible by 100. And so now I know for sure that if a year is divisible by 4, then it is in fact a leap year. And then now at this point in my function, I know that it is not a leap year. So I'm just going to say return false. If I make it to this point in my function, I know that it's not a leap year. Okay, couple things I just want to say about this code. Feel free to chime in if you have any questions about this. But often students aren't sure why I don't need to say else here. The answer is that if year modulus 400, if year is divisible by 400, I actually get this return true statement, and that immediately ends the whole function anyway. So I don't need to say else here. I know that if I reach this point in my program, then I know that year is not divisible by 400. Okay. That's observation number 1. Anybody want to ask a question? Okay. Observation number 2 I want to make is that this code can be pretty easily simplified. And this actually corresponds to one of the style conventions you're going to see. So what I want to say is, let's look at what these last 3 lines are actually saying. Right? So at this point in my function, I'm saying, okay, if this condition is true, return true. If this condition is false, I'm going to return false. So basically what I'm saying here is, whatever that condition evaluates to, return that. Right? So instead of saying all that, I'm just going to say return year modulus 4 equal to 0. Same thing. So in other words, this one simple line of code is exactly equivalent to those lines of code. Anyone want to ask a question about that? Want me to say it again? Okay. Good. Let me also another observation that comes to mind. I could attempt to actually combine all of this into just one single very complicated logical expression, which a lot of programmers would probably do. If you Google, C++ expression for leap years or something like that, you'll probably find that. My personal opinion is that if you're trying to write code that's easy to read and understand, this is easier to read and understand than that big, long, complicated logical expression is. So I'm just telling you that my opinion about that, and that other expression is out there. You could use that too if you prefer. I don't think we'll actually be doing any assignments where you need this, but we will be seeing it again in the lecture examples, I think. All right, any last questions before we go? Anything we need to talk about? This is it for functions. You have a assignment related to functions that's due on Monday, and then we'll be diving into arrays. I think that's all I have to say.
Quick question. So
Sure.
could you just rewrite every if statement as return year modulo,
No,
100?
no, certainly not.
Okay.
This is a very precise pattern, right? It has to be if condition return true, followed by a return false. That you can rewrite, but that pattern doesn't occur anywhere else in this code, right?
Okay.
So you just have to be sure that it really matches the pattern exactly. Okay. I mean, there probably are ways to rewrite this, but they're more complicated and it would cause you to end up with that very complicated logical expression that I was talking about a few minutes ago. All right, there actually could be syntax errors in here. I don't know. We haven't actually executed this right, but we're out of time and it's close enough. So if there are no other questions or comments, I'm going to go ahead and end the meeting, and I will see you all on Monday.
Thank you.
Thank you.
Thank you. Have a great day.
All right, you guys too.